This equation has two variables. There are infinite solutions, and each solution is an ordered pair, and we write an ordered pair with the x value first, followed by the y value. Some ordered pairs that are solutions to this equation are 0, 3, 1, 5, -1, 1, and -5, -7. We can graph these four ordered pairs, and we have, and you can see they line up. They're called collinear points. And we can draw a line through them, and we put arrows on each end of the line. The line represents the infinite pairs of points that are all solutions for this equation. Here's another equation. One way to graph an equation like this is to make a chart. And generally, we start by picking a number for x. I like 0. It's easy to work with in this case. -3 times 0 is 0. 0 plus 4 is 4. I write the 4 and I graph it. There's my first point. Now I've picked -1. -3 times -1 is +3, and 3 plus 4 is 7. And now I'm going to pick +1. -3 times +1 is -3, plus 4 is +1, so I graph 1, 1. And finally I pick 4. -3 times 4 is -12, plus 4 is -8, and I graph that as well. And once again I have 4 points that line up. You may have heard the statement, 2 points determine a line. This is true. If your arithmetic is excellent, you can get a graph of an equation by finding 2 points. I usually do 3 or 4 points to make sure that I haven't made any arithmetic errors. I connect these 4 points, I put arrows on the end, and the purple line represents all of the solutions for the equation y is equal to -3x plus 4. Here's another one. I've already put 4 choices for x, and I picked those 4 choices because of the 2/3. I want ordered pairs that are integers. I don't have to graph just integers, but they are easier to graph. And because the denominator of 2/3 is 3, I picked 4 numbers for x that are all divisible by 3. We'll start with 0. 2/3 of 0 is 0, and 0 take away 3 is -3. So I write it down and graph it. 2/3 of 3 is 2. 2 take away 3 is -1, so I graph 3 and -1. Then I look at the 6. 2/3 of 6 is 4. 4 take away 3 is 1. I write it, I graph it. And finally, 2/3 of -6 is -4. -4 take away 3, of course, is the same as -4 plus -3. -7. I graph it. I'm happy. They line up once again. I connect them, put arrows on the end, and I now have a graph that represents all of the solutions for the equation y equals -2/3 x take away 3. Here's one. It's not solved for y. It's a little more problematic. Sometimes you can still figure them out, but sometimes it's easier to solve for y first. I'll leave it up to you. If you don't remember how to solve for y, see Lesson 22, Literal Equations. Well, one way is to pick 0. Zeros often are easy to work with, so if 2 times 0 is 0, then we just have to think 3 times what makes 12? Well, of course, that's 4, so we write it and we graph it. And then we say, well, what if y is 0? Well, then if 3 times y is 0, 2 times x has to be 12, and that's not difficult. That's 6. But to get 2 more, you might have to do a little trial and error, play around a little bit, and that's where using the other method where we solve for y first might be quicker. But I have found 2 others. I found -3 and 6 work, and also 3 and 2 work. They line up, I connect them, and I put arrows on the end. Once again, I have a line that represents all of the solutions for the 2 equivalent equations up at the top. Here's an unusual one because there's no x. So I've picked 4 numbers already, and then it dawns on me, no matter what x is, y is going to be -4. Or another way to write it to help understand, what it really means is that 0 times x plus 1 times y equals negative 4. But once again, no matter what x is, y is always negative 4. So this is a horizontal line, and so this is what I call a special case equation. One more special case, x is equal to 6. Well, once again, this could be rewritten to help us understand it. 1x plus 0y equals 6. So no matter what y is, x is always 6. And now we have a vertical line. So we have several good examples and then two special cases, the special cases being vertical lines and horizontal lines. To summarize, equations such as this one, y equals 2x plus 3, have infinite solutions. Each solution is an ordered pair, written x followed by y. If we find a few solutions and graph them, the points will be collinear. Connecting the points will give a line that represents all of the solutions for an equation.